Students are taking very lightly about the solution work and uh, other work of the subject. But it will hamper your study as well as your term of marks. Maybe the student they are thinking that they will escape or at the last moment they will complete all the things. They should know that in industrial building they have to design the roof truss, they have to design a column, they have to design uh, the design, the gantry girder, and they have to design the column bases. Then only their industrial building will be completed. And with the design, you have to make a drawing sheet also. So they don't lightly complete the work as it is expected. I think so. You will now take a serious and you will complete the work as and when required. Okay. So please take it seriously, study well, do the work regularly. Otherwise, you will not able to understand this subject. This subject is very vast, and a very good point of this subject is that numericals are large and will not lose the marks as in the theory subjects. So I request all of you, please join on time every lecture and also complete the work as required. Okay, so I think so. We have to start the lecture because already we have already passed 7 minutes to start the lecture. Okay, so already in industrial building, I have covered the functional planning. I have covered the uh, your I have covered the your head load, line load, and window analysis. Also, we have make a figure for the vector scalar diagram, space diagram to calculate the internal forces of the rotors. So I will go fast. I will go fast so that you can understand what I will cover in the next video. First, I have given this exam problem to all of you. This mini project and industrial building as per the batch wise, as per the roll number, as per the roll number. So as per the roll number, you have to complete your industrial building, and these are the problems given as per the roll number. Already this sheet is shared on your WhatsApp group also, on your Google Classroom also. The students they have not joined till date their Google Classroom. They are losing it because lots of learning materials, videos are region, the dimension of same in Latur region we are calculating. This just example is not given here that I am taken for myself, and in that already we have covered this industrial building example. What is the panel point load? How to calculate the that is nothing but spacing of truss and spacing of purlin in plan. And then we have started dead load on roof truss. For the roof truss I have selected. You have to select your roof truss as per the example given. As per the example given, you have to choose your roof truss. Okay. So these examples already I have given to you. Okay. And if you are facing any problem, you will come to me, you will meet me, and you will complete your work. Students who are interested, they are coming, they are discussing over how to draw the sheet, how to calculate these forces, and I am guiding to them. They are coming physically, or if you have any doubt, you can ask with me by sharing your calculation with me, and I will guide you. So in roof truss, there are four main types of member: principal rafter, ceiling, tie member, and strut. Okay, and then we find out the find bed load on the roof truss. It consists of cell weight of roof truss. In the plan area, it is between 100 Newton per meter square to 150 Newton per meter square. And weight of routine sheet, as per the GI sheet. As per the GI sheet or S sheet, this type of sheet you are using, we are calculating the loads, dead load due to the roof truss. Weight of purlins, it may be assumed 100 Newton per meter, and if your purlin weight is more than that, you have to revise the calculation. Weight of the bracing is over the plan area. It can be assumed around 12 to 15 Newton per meter square. Now the dead load you have to calculate on the plan area, on the plan area, on the slope area, roof of weight of roofing sheet, and then the running meter, the weight of your purlin. All this will give the dead weight on your panel point. And area, you know, area in plan, you know, area in slope, you know. So you can multiply this, and you will get the your required dead load on your panel point. That is coming at the middle point is coming 1.8 kilonewton. This is already we have considered. Okay. Then lie load analysis as per the IS 875 part 2. Part 2 में का जो IS 87 part 2 है लाई लोड के लिए. IS कोड भी मैंने आपको सब बताया था कौन कौन से IS कोड आपको यूज करना है. तो ऑनलाइन लेक्चर्स में हमारे IS 875 part 1 is for dead load, IS 875 part 2 for lie load, IS 875 part 2 2015 this current load, this IS 875 part 3 2015 it is for the wind load, and IS 800 2007 for your design of steel structure guideline for the design. Okay, so already we have gone through all this thing IS codes, and based on the IS 875 part 2 lie load analysis is done. If axis is provided and if theta is less than 10 degree, then it is 1.5 kN per meter square, or you can write on 1500 Newton per meter square. If axis is not provided, then 750 Newton per meter square, that is 0.75 kN per meter square. If slope is greater than 10 degree, and in our case the slope is around, it is coming 18.43 degree, which is greater than 10 degree, then we have to find out the lie load on the purlin, that is 750 minus theta minus 10, theta in our case 18 minus 10, and it will come around 168.5 6 Newton per meter square, and we find out 580.4 Newton per meter square. It is greater than 400 Newton per meter square. That is check given in the IS code. So lie load on truss is nothing but 2/3 of lie load on the purlin. Then we find out the lie load on purlin. Then we find out the lie load on panel point, and lie load on panel point at mid point is coming 2.2 kilonewton. That also we are drawn here. Then we have calculated wind load on the wind load. Generally it is acting normal to the sheeting. So this is our slope. Okay. Generally the wind load is acting normal to the sheeting or perpendicular to the sheeting. Okay, and it is uplift. It is not gravitated. Whereas the dead load and lie load are acting downward, and they are gravity loads. So in this panel, in this fashion, the lie load and dead load are okay. So they are gravity loads, but wind load are acting perpendicular to your sheeting or normal to the sheeting. So this is nothing but the wind pressure or wind load acting on the so lie load on panel point of truss we have calculated, dead load we have calculated, and wind load is also we have calculated by using the wind load analysis IS, the code IS 875 part 3 or revising to the 150. So this is also we have calculated, and the wind load on the panel area is coming 4.8 km. Okay, all these loads we have calculated, and the members also we have selected, and then we have drawn also the key plan, key elevation and key plan of your industrial building. The key plan of your truss is showing the lower chord members, is showing the upper chords members. Okay, you have to write down. And here, the first member having a zero load, that's why this member is called as dummy member. So we are not considering in frat type of truss this type of member. Okay, so we are not considering this type of your member. Okay, this is the ridge line, the use line at the end, and this is the purl. Okay, so this is the key plan of the truss, and then we have also drawn the for the dead load analysis the live load analysis, dead load analysis. We also drawn a space diagram. So this is given by the Bowes notations we also know, and Bowes is given this how to draw the space diagram. The space diagram means we are naming the in the space. If you see in this figure, this dead load analysis, from this dead load and lie load analysis, we have this dead load analysis. Where is that figure? Sorry. So I think so. This is the dead load analysis. We have got this load, and that I have transferred in the AutoCAD to show you. Drawn AutoCAD and to show. So this is in AutoCAD we have drawn this. And this is the space diagram. Why it is called as the space diagram? Because as per the dimension, so we have taken the scale here, scale 1:100, scale 1:100. Okay, so this scale we have drawn. The key plan is also we have drawn into the scale, and the same key plan we have taken for the space diagram. So this person is always joining late. This Amos Sodagar. I don't know what he is thinking about that. He's thinking himself very smart, and every time he's joining late. Every time, after half an hour, he's joining the lecture. Uh, and also, the other next time I will not allow you into the lecture. It is not यदि आप इसको धमकी मत समझिए, मैं आपको माफ करते जा रहा हूँ, आप कभी भी लेक्चर में ज्वाइन होते हैं तो यू शुड अवॉइड दिस, अदरवाइज आई विल नॉट टेक यू। 11:10 का लेक्चर है, 20 मिनट बाद आप लेक्चर में ज्वाइन होते हैं, ओके। और ये एक बार का नहीं है आपका, दिस यू आर डूइंग, चलो एक बार है तो कोई बात नहीं। इफ द पर्सन विल बी ज्वाइन after 10 minutes in the practical class, I will not allow them. The person they are joining after 5 minutes in lecture class, I will not join them from the next time. You should keep in the mind, okay? So don't take it easily, okay? So this already up to that in our plan, this we have space diagram. Space diagram in external forces 0.9, 1.8, 1.8. These are the space diagram, and reaction at L0 and reaction as L8 is nothing but 9 kilonewton and okay. So this is the space diagram we have now. Why we are drawing this space diagram? To draw a vector diagram. And from the vector diagram can easily find out the internal forces by graphical method. Because the numerical method to find out the internal forces of member of truss, it is not so easy. It is laborious work. But graphical method you can easily find out the internal forces of your truss. That's why, or also you can learn the graphical method, how to find out the internal forces in the member of truss. So here member of truss, क्या member of truss है? अगर हम यहाँ देखें तो L0, U1, U2, U2, U3, top chord member of truss, and they are nothing but the rafters. Here you can see L0, L1, L1, L2, L2, L3, L3, L4. They are the bottom chord member of truss, and they are generally called as tie members. So in gravity load they are in tension. In gravity load the rafters are in compression. Then the vertical member you can see L4, U5, L3, U4, L2, U3, L1, U2. These are the vertical component, and they are called as ceilings, and they are tension in the gravity load or compression sometimes. And the inclined member, you know this L1, U1, L2, U2, L3, U3, L4, U4, L4, U6, L5, U7, L6, U8, L7, U9. So all these members are strut, that is inclined member of truss, and stress are in compression. It may be vertical, it may be inclined in the gravity loading. Okay, so these are the member of truss, 4 types member of truss, and the member of truss, we don't know the internal forces. We know the external forces we have calculated. So at L0, I will write down R. L, it is 9 kilonewton. R L8, 9 kilonewton, both sides because of symmetricity. Now you can see in space diagram, I have given the capital alphabet letter between, in between the external forces are there. In between the external forces are there. So if I will go for A to B, the external force is 0.9. तो बेटा एचओडी के पास जाइए ना। तो किस किस में चल जाएगी? हाँ मैकेनिकल उधर नीचे ग्राउंड फ्लोर है, नीचे से कोई निकल जाएगा। तो यहाँ पर थोड़ा डिस्टर्बेंस था, तो सॉरी फॉर दैट। तो अगर हम लोग क्या कर रहे हैं स्पेस डायग्राम में, आप देखिए कि यहाँ आपको ए टू बी कौन सा एक्सटर्नल फोर्स है, 0.9 किलोमीटर एट द एंड ऑफ योर ट्रस। देन अगर U1 पर हम देखते हैं, ज्वाइंट U1 पर, तो 1.8 किलोमीटर मिड ऑफ द ट्रस। ओके, दैट इज पैनल पॉइंट एट द मिड। देन सेकंड पैनल पॉइंट U2, द ज्वाइंट U2 अगर देखें वहां पर भी फोर्स कितना है हमारा एक्सटर्नल फोर्स 1.8। तो इन सब के बीच में मैं स्पेस में नाम दे रहा हूं, अल्फाबेटिकल नेम दे रहा हूं। कौन सा नाम दे रहा हूं, अल्फाबेटिकल। एक्सटर्नल फोर्सेस के बीच में A B C D E F G H I J K L। अब उसके बाद L के बाद यहाँ पर एक्सटर्नल फोर्स कौन सा है, ये रिएक्शन है हमारा L टू M, और M टू A, ये भी क्या है, रिएक्शन। समझ में आ गया। तो इस तरह एक्सटर्नल फोर्स के बीच में जो मैं नाम देता हूँ अल्फाबेटिकल कैपिटल अल्फाबेटिकल नेम अगर मैं देता हूँ, इसको क्या बोलते हैं, स्पेस डायग्राम। इसी तरह इंटरनल फोर्सेस में इंटरनल मेंबर्स के बीच में मैं नाम देता हूँ। देखिए यहाँ पर 1 स्पेस में नाम दे रहा हूँ, 2 ये स्पेस में नाम दे रहा हूँ, 3 स्पेस में नाम दे रहा हूँ। अगर आप देखेंगे 2 कहां पर बाउंड है, U1 U2 और L1 के बीच में, L1 L2 और U2 के बीच में 3, L2 U2 U3 के बीच में 4। इस तरह स्पेस में मैं इंटरनल इनसाइड जो स्पेस है ट्रस का, इनसाइड जो स्पेस है उसमें मैं नंबरिंग से नाम दे रहा हूं 1 2 3 4 5 6 अप टू 16। तो ये लास्ट वाला मेरा क्या है, ये 16 है। ओके, तो likewise you have to give the naming in between the spaces, external spaces के बीच में जो नेम देंगे that is the capital alphabet, and internal जो स्पेस है ट्रस के बीच में ओपन वेब जिसको बोलते हैं, उसके अंदर अगर हम नाम देंगे तो वो नंबरिंग से। तो दिस डायग्राम इज कॉल्ड एज स्पेस डायग्राम। आप लोग कैमरा ऑन रखिए और मेरे क्वेश्चन का आंसर दीजिए, वरना आपको समझ में नहीं आएगा। ओके, तो अगर आपको कोई डाउट है, कोई प्रॉब्लम है, फिर आस्क विथ मी, और हम वहाँ रुक कर आपका जो डाउट है वो क्लियर करेंगे। ये स्पेस डायग्राम मैंने आपको व्हाट्सएप पे भी शेयर किया था, और ये वीडियो में भी अवेलेबल है, जो रिकॉर्डेड वीडियो है। तो आई थिंक सो आप लोग मेरा लेक्चर, जो रिकॉर्डेड लेक्चर वो देखते होंगे रेगुलरली, और उसको आप शायद साइड बाय साइड अगर पसंद आए तो लाइक कीजिए, और वैसे भी अगर आप ध्यान से देखेंगे और रेगुलर देखेंगे तो ही आपको समझ में आएगा वीडियो। अदरवाइज आप गैप करके देखेंगे तो गैप होने की सूरत में आपको नहीं समझ में आएगा। नाउ बेस्ड ऑन दिस वी हैव टू फाइंड आउट द इंटरनल फोर्सेस ऑफ मेंबर। इंटरनल फोर्सेस ऑफ मेंबर अगर हमको मालूम करना है तो मैं अब क्या करूंगा, इसके लिए वेक्टर डायग्राम मालूम निकालूंगा। ओके, तो यहाँ पर मैंने क्या करना है, स्केल लेना है, स्केल लेना है। यहाँ पर स्पेस डायग्राम मैंने बनाया जो स्केल से आप भी बना सकते हो ऑटोकैड में, लेकिन आपको फ्री हैंड बनाना है। आपको ये ऑटोकैड में नहीं बनाना है, ये जस्ट इसके लिए आपको समझाने के लिए मैं ऑटोकैड में बना रहा हूँ। ठीक, आपको जितनी भी फिगर है अप टू शीट नंबर 7 सब आपको हैंड ऑन है। कौन सी है, हैंड ऑन। अब यहाँ पर मैंने जो स्केल लिया था, एक्चुअल द नेमिंग ऑन द शीट शुड बी so scale you have taken here 1:100 or 1:1000. स्केल क्यों लेते हैं हम लोग? स्केल यानी अगर एक सेंटीमीटर यहाँ पर है तो 100 सेंटीमीटर आपके ग्राउंड पर है, स्केल हमको लेना पड़ता है। तो यहाँ पर स्केल मैंने लिया है 1:1,000। जब हम इसको देखो तो ये 1500 mm होगा। तो अगर mm में हम लोग ने लिया है तो इट इज 1:1000। तो स्केल हियर यू हैव टेकन 1:1000। ओके, जैसे 1 mm यहाँ है तो आपके ग्राउंड पे कितना 1000 mm यानी 1 मीटर। ओके, नाउ वी विल टेक हियर फॉर वेक्टर डायग्राम स्केल। So we will draw a vector diagram. I will copy this. I will write here vector diagram. कौन सी डायग्राम? वेक्टर डायग्राम। वेक्टर डायग्राम and scale I will take 1 kilonewton. 1 kilonewton. Always K is more in kilonewton and K. Scale I will take 1 kilonewton is equal to 1000 mm. So I will take 1 kilonewton is equal to 1 meter. 1 meter. K is also small. K in kilo is always small. K in kilo is always small. बड़े ध्यान से देखेंगे ताकि आपको समझ में आए किस तरह हमको वेक्टर डायग्राम बनाना है। तो मैं यहाँ पर ले रहा हूँ 1 स्केल 1 किलोमीटर इज इक्वल टू 1 मीटर 1000 mm। अभी हमारा आई विल स्टार्ट फ्रॉम द लेफ्ट साइड ए टू बी 0.9 किलोमीटर है यानी 900 mm। So I will draw, I will take the line and this force is downward, so I will draw A to B downward force. It is a straight line, straight, so it is 900 mm. I will write down. We change the layer, I will change the layer, it is not dimensional layer, so it takes some this, okay, and thickness I will increase so that it is visible to you. We increase the thickness more than this 0.6, or I will take 0.5 is better. Okay, so this is from A to B, and I will also name this diagram vector diagram. Okay. Please understand this. A to B. Now, when you are writing here, it should be small letter. Should be small letter. A to B. 900. No, so I will write on 900. Okay. Now B to C, the external force 1.8 kilonewton. 1.8 kilonewton, yani 1800 mm. 1800 mm. 1800. I will take line is also downward, so one said 1800 mm. Because 1 kilonewton I have taken 1800 mm. So this is the point C. So I will write the, because it should know after that because point is not seen. So this one is B to C is 1800. Again, if you see the C to D, D to E, E to F, F to G, all are 1.8 kilonewton. 1.8 kilonewton. So I will write down. I will just simply copy. I will just simply copy how many times? C to D 1, D to E second, 4, 5, 6, 7, 8, 8 times. I will copy this 1, 2, 3, 4, 5, 6, 7, 8. तो ये हो गया 8 A से B, B से C 1.8. Then C to D, D to D, again 1.8, D to E, again 1.8, E to F, again 1.8. You can see here, E to F, again 1.8, F to G, again 1.8, to G, again 1.8, GH, again 1.8, H के बाद I, HI, IJ, again 1.8, O, HI, then I to J, again 1.8, J to K, again 1.8. These all are small letter, huh? In vector diagram you have to write this one. J to K. Now K to L it is again 0.9. I will draw this. 900 mm, 0.9 meter. 1 kilonewton we are taking here. K to L. I will copy and this is the point L. Write down this is the point L. Small letter. Okay. So this is our, I am drawing, this is our vector diagram. I am drawing this vector with scale. Scale क्या लिया मैंने? 1 kilonewton equals 1 meter. No, 1 meter. Now, here is a reaction. Reaction you can calculate manually. All downward forces and they are equally distributed at two types. Two supports are there. तो डिवाइड बाय 2 आप करेंगे तो आप देखेंगे 1 2 3 4 5 6 7 8 9 10 0.9 1.8. So 10 into 1.8 is 18 kilonewton. 18 divided by 2, 9 kilonewton. Both sides reaction will come at L0 and node L8. Okay. Now the reaction upward L to M. L to M. So L to M कितना है? 9 kilonewton. यानी 9 kilonewton means 9000 mm. Okay, यानी 9 मीटर. तो अगर मैं 9 मीटर ऊपर के लिए आऊं तो मेरा 9 मीटर अगर यहाँ से मैं देखता हूँ यहाँ से तो यहाँ पर आएगा. यहाँ पर मिड पॉइंट पर है. ये मिड पॉइंट पर हमारा देखिए कितना आ रहा है. इट इज कमिंग 9000 mm यानी 9 मीटर. I will write down this is reaction which is 9 kilonewton. So it will be upward. So this point at junction I will small circle I will draw at midpoint. This point is nothing but M. So I will write this point as a M. So this midpoint, this is nothing but our small m. Small. ओके. तो यहाँ तक आपको समझ में आ गया सबको वेक्टर डायग्राम किस तरह. अभी एक्सटर्नल फोर्सेस अगर M to A आप जाएंगे तो कितना आना चाहिए? 9 किलोन्यूटन. तो आप देखेंगे यहाँ पर स्केल मैंने दे दिया 1 किलोन्यूटन इक्वल 9 मीटर यानी 9000 mm. अगर M to A आएगा तो यहाँ अगेन आप देखिए here 9000 mm, yani 9 kilonewton, because the scale you have taken 1 kilonewton equal to 1 meter and 1000 mm. So it's showing in mm 9000 mm. Okay, so M to A, our reaction is well, so we will yani okay. So all the external forces work we have done. Now we have to find out the internal forces and we have to join or each member parallel to this. अब यहाँ पर देखिए, अगर M से 1, U1 और M1 है ना, तो यहाँ पर देखिए B1 A to B is vertical, but B to 1 is the incline, and M to 1 is also inclined. तो अगर M to 1 में लाइन एक्सटेंड करता हूँ, M कहाँ है हमारा, दिस इज द सेंटर M. अगर कुछ ऐसा हो जाए तो रीजन बोल के टाइप करके आप so you can take a line at the center from the end, okay, and parallel to, I will draw parallel to M to 1. M to 1 is the horizontal line, so from this I will draw the parallel line M to 1. Now B to 1 is the inclined line, this inclined line. I will copy this, the parallel line, and I will, this parallel line should meet at B to 1. So B कहाँ है हमारा, B point है, B to 1. I will extend this line. Oh, where this M to 1 and B to 1 meet, that point is 1 point. So I will write copy is our 1. So this is our 1. आपको समझ में आ रहा है पिक्चर डायग्राम किस तरह बना रहा हूं मैं फॉर अंडरस्टैंडिंग? तो यहाँ पर जो मीट होगा ये क्या हो गया, M to 1 and B to 1. Again 1 to 2 is this line, this, so from this the parallel line will be drawn. So I will draw the parallel line against this. So 1 से ये होगा, 1 से 2, 1 to 2, this parallel line 1 to 2, and 2 to 3 is vertical line, and 3 to M is horizontal line. So 2 to 3 I will make it. I will draw the parallel line, and 2 to C again inclined line. 2 to C again inclined line. I will write here C, and when these 2 points meet, I will extend this. This point is nothing but, so this point is nothing but the second point, the intersection of this second. Okay. And 2 to 3 is vertical, and 3 to M is, so I will write down, I will draw this figure. This is perpendicular to the M, which it is meeting at the end. So 2 to 3 and 3 to M. So this point is, I will write down, this point is our third point. This point is our, okay. Are you getting how I am drawing? So I will draw these lines. It is very clear to me. Now 3 to 4. 3 to 4 again inclined line, and 4 to D again inclined line. I will take this first 3 to 4, this inclined line. We started from 3. I will draw 3. And 3 to 4 again straight line, that is for parallel to D, is parallel to C, 3 to D, from the D. Where this two meet, okay, so this is nothing but point, this is nothing but point 4. This is nothing but point 4. Nothing but point. Okay, now again you can see the 4 to 5 vertical line. Copy this. Because we have to draw the parallel, we will take this and parallel to this 4 to 5, and 5 also meet at M. 5 to M is horizontal line. So 5 to M. Okay, this horizontal line is 5 to M. So this point is 5. Point is 5. Where this vertical line meets, that point is 5. Point is 5. Then again 5 to 6 again inclined line, and 6 to E again inclined. So 5 to 6. Slope is changing, so I have to change the slope. 5 to 6, and it's again lead to the 6 to. So this extend. Okay, so that is nothing but your edit 6 point. And again 6 to M is horizontal line. 6 to M, 6 to E is inclined line. 6 to E is inclined line. It's that one. Now 6 to 7 is vertical line, which is 7 to M is the horizontal line. Horizontal. And 6 to 7 is vertical. I will draw 6 to 7 and extend to the M. You will get the point. So this is nothing 0.7. I will write down here. This 0.7. Okay. Now again 7 to 8 is line line, and 8 to F is also inclined line. So 7 to 8 is, and sorry, copy is F2. So this one is by extend. Where this meets 7 with the F, that is our 8 point. This is our 8 point. This is our 8. Okay. Now 8 to 9 again vertical, and 9 to 10 again inclined. I will write down 8 to 9, 9 to 10 inclined. We don't know this. I will draw it. I don't know where is the 9 point. This is S point. and 9 is G to 9. We incline with this G to 9. G is opposite of this here. I will extend this till it met with the 8 vertical line, then that is nothing but this is nothing but the point 9. This is point 9. To do symmetrically, it is coming exactly opposite to the 8 point. Due to symmetricity in the truss, it is coming exactly opposite to the 9 point, 8 point. Okay. Similarly, if you go for that 6 to 7 on 7, if you go for opposite, then the 9 point, then 11, then 12, then 13, you will get that. Okay. So in opposite direction, the members and forces are same when going for that. Otherwise, you can draw. So this is nothing but the vector diagram, and from the vector diagram, you can we can draw a force table. From the vector diagram, we can draw a force table for dead load, for live load, for wind load. This is vector diagram for the dead load. This is vector diagram for the dead load. So how you can draw the vector diagram? Give you the force table, draw the force table, and find out the member internal forces if you dead load. You can write down. Okay. So that is nothing make a force table, and exactly opposite all the things will come in case of. Okay. So come to part B, let's draw the force table. So I will show you how to draw the force table. You can draw on feet only, and the forces of the member is shown. Forces of the member. Okay. Force table we need to draw. We will make the force table and the forces of the members we will write down. Okay. So I will draw the force table, or we can insert the force table from the Excel sheet. We can insert here the table. We can form the table. Okay. I will write down here. We will prepare or make a table. Insert table. So there is table available. Or insert. Insert. I will prepare a table, I think so. Prepare form. This is table. You have to create a table. A table is compound object, contains data in rows and columns. Okay. So I will insert a table. I will insert a table. Okay. So number of columns are required 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns are required. I required 11 columns. I write up 11 columns are required. And number of rows are required around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 19, 20, 21, 22, 24, 24 plus 4, 28. So I required data rows around 28 rows. Okay. And the table title. Title of table you can write. Start from empty table. So I will start from the empty table. I will prepare a table here. This is my table. This is my table. And the table is looking very small. The table is looking very small. I will make it large. Make it large by scale. So I can scale the table. I will scale the table with 20 times. Again, you can scale the table. Scale the table. Again 20 times. Twice now. I will undo. So this is okay, I think so. And we'll manage the writing and there. Okay, this is the our table. Table I have inserted. Okay. Write on table. Number. This is the title. Truss analysis by graphical method. First row. It's universe. Join this first two row. Join this first two row. For joining, write on the merge cell. Inverse. Okay. Font size is too large or width of column you can increase. Width of column, here column width I will increase, or I can decrease the font size. Okay. Select the column and decrease the font size. This should be here. Change the layer. This is layer. Blue. This is the layer I do. Line type. Line width you can reduce. Okay. Now table standard number of rows and columns is there. These are the properties. These are the properties of table which we are changing for our table width, column number of column, position geometry. Okay. Table geometry, table text. Text, I'm searching where is the text. How to change the text in the text dialog. Okay. So I will change the text. Text I will take the Roman. Okay. And size of text should be less than okay. Okay. This is the members. I will members. Members they may be positive or negative. The width of column you can increase by this arrow. Okay. You increase this arrow. The width of your column is increasing. Okay. The width is increases. Now you can write down members. see, click on here, go to number should be Roman, should be so, and I will copy this, Control C, and put the uniform for all the rows and columns of the paste. Okay, I will paste. Okay, and here our title will be there. Title, the truss analysis, internal forces of truss, internal forces of truss, by which method we are solving? Here head load, live load, then wind load. These three loads we are considering for the design of wood truss. Okay, then you take the load combination. Okay. Combinations. You will take 4 types of load combination, and then design load will select from the load combination, design load, and then we will select the length of member which we are going to design. Length of member. This is the work point. Now, so the load generally we are denoting. So we are here. The compression force is negative. Okay. And tensile force is generally steel structure is considering positive. Okay. Dead load we are denoting by DL, live load we are denoting by the LL, live load. Wind load we are denoting by WL. Load combinations, different combinations we are selecting. I will merge this for the load combination. Merge this, merge one. Okay. So combinations. So here it is 1.5 times of dead load plus live load. Second 1.5 times of dead load plus wind load. Third 1.2 times of dead load plus live load plus wind load. And fourth is 0.9 in bracket dead load plus 1.5 times of wind load. These are the different combinations of load. Okay. All values in kilonewton. In the design load in kilonewton, and member length we will consider meter. Okay. Now first member in our case First member in our case, is principal Rafter. Principal Rafter. Okay. Then principal Rafter. If you see the principal Rafter, the top chord member of truss L0U1 to the U9L8. U9L8. So generally, if you see the principal Rafter, L0 U1 to U9 L8, both are the same. Symmetricity is there. Okay. Second, U1, U2 is same as U8, U9. ओके, तो अब यहाँ देखिए आप ट्रस में तो L0U1 is same as U9L8. Similarly, U1 U2 is similar is U8 U9. इसी तरह U2 U3 is similar to the U7 U8. So that's why I am writing here. Okay, this is the rafter. This is our principal rafter. Okay, principal rafter. Yeah. Now I am writing here L0U1. All this we will cell will middle center. So all cell we will choose as the middle center. Here middle center. Here also all cell we will select middle center. So all the value will come at the mid. Okay. So done this. It also we will say select middle center. Okay. Now from this you can increase the row size or decrease the row size, depend on you. Okay, so in principal rafter L0U1, U9L8, U1 U2, U8 U9 they are same. Similarly, U2 U3 is same as U7 U8. Okay. Similarly, U3 U4 same as U6 U7. Okay. Similarly, U5 U6 sorry U4 U6 U4 U5 is same as U5 U6. This is the member. This is the principal routers. This is the principal router. Now we'll come to the bottom member. Come to the bottom member. Okay, this bottom member. I will merge this. Merge all. Okay. I'll copy this. Control C. Control V. The main member bottom tie. Main member bottom tie. Bottom tie. bottom tie L0, L1, L0, L1 is equal to L7, L8, L7, L8. Similarly, in bottom tie, L1, L2 is same as L6, L7. Similarly, L2, L3, L2, L3 is same as L5, L6. Similarly, L3, L4 same as L4, L5. L4, L5. So this I am selecting from the geometry. What we are giving the nodes. L0, L1 आप देखेंगे ये सेम है L7, L8 के. L1, L2 सेम है L6, L7 के. L2, L3 सेम है L5, L6. सिमेट्री है, ज्योमेट्रिकल सिमेट्री है ट्रस की, इसके लिए ऐसा आया. अगर ज्योमेट्रिकल सिमेट्री नहीं है तो सब आपका ये अलग अलग आएगा. ना ज्योमेट्रिकल सिमेट्री है, दैट्स व्हाई मैं कंबाइन कर रहा हूँ. ओके, ये बॉटम टाई हो गया हमारा. राफ्टर हो गया, बॉटम टाई हो गया. नाउ वी विल गो फॉर द सीलिंग. ये वर्टिकल मेंबर्स जो है L4, U5, L3, U4, L2, L3, these are the vertical members. I will write down vertical members is nothing but ceiling. So I will write down here Control C. यहाँ पर आपका ये चेंज हो जाएगा Control V. लेकिन ये क्या है, बॉटम टाई नहीं है. Either it will be take a strut or you can take a. तो स्ट्रट क्या है, स्ट्रट हमारा इंक्लाइन मेंबर होता है. स्ट्रट क्या है, हमारा इंक्लाइन मेंबर. इंक्लाइन मेंबर में अगर हम देखें तो विल स्टार्ट, तो आप देखेंगे इंक्लाइन मेंबर में तो U1 L1 is nothing but same as L7 U9 or U9 L7. Okay, so you have to write down this. I will write here. स्ट्रट मेंबर अगर हम लेते हैं तो पहला मेंबर हमारा रहेगा U1 L1 सेम एज U9 L7. Similarly, U2 L2 is same as U8 L6. Similarly, U3 L3 is same as U3 L3 same as U7 L5. Similarly, U4 L4 is similar as U6 L4. Okay, this is nothing but your strut. Now we will go for the series. Control V, and right here is nothing but ceilings. The vertical members are called as ceilings. Okay, vertical tie or vertical members are called ceilings. So we are seeing here L4 U5, L3 U4, L2 U3, L1 U2. Here L5 U6. So you can see that L4 U5, then L3 U4 is nothing but L5 U6. They are similar. Okay. So I will take the ceiling. This is the vertical member of truss. They are called as ceiling. I will write down ceiling. I will write down ceiling. Ceiling size write down. U1, L1, U2, L1, U2. The same as L7, U8, L7, U8. Similarly, L2, U3, same as L6, U7. Similarly, L3, U4, same as L3, U4 is same as L3, U4 is same as L5, U6. Because of truss symmetricity, okay. Now L4, U5, L4, U5, same as L4, U5, L4, U5. So these are the members of truss, and now we have to find out the dead load of. I will delete this. This is the extra rows which are not required. Where is delete? ओके, तो इसी तरह यहाँ पर आप देखिए कि चार टाइप के रिवर सीलिंग हैं 1 2 3 4 1 2 3 4 ओके। तो सब मैंने लिख लिया। अब डेड लोड किस तरह मालूम करेंगे? राइट डाउन हियर। डेड लोड हमको मालूम करना है। L0U1 मैं लेता हूँ नंबर L0U1। L0U1 कहाँ है? L0U1 L0U1 यानी B21। B21 कितना डिस्टेंस है? I have to measure. I have to measure B21. B21. So I will measure B21. I will measure the B21. I will convert into the dimensions, and it not required much exercise. Okay. If I measure B21, B21 is distance. This distance is how much? 25,614, 25,614. So it will be because it is the principal rafter, the compression member is the negative value. That's why it is rafter in the gravity load is like negative value. That's why this is minus 25.61 kilonewton. Okay, so I will write down here. Dead load in kilonewton. Write kilonewton. Live load in kilonewton. Kilonewton. And loading kilonewton. Okay. The combinations are also in kilonewton. Kilonewton. So likewise, to make the force table, kilonewton, also in kilonewton. At the length of member in meter, the design load that we will select that will be. समझ में आई है? तो लाइक वाइज यू हैव टू फाइंड आउट। तो पहला L0 U1 U9 L8, this is nothing but this. So this distance is 25,640. Our scale, what we have taken scale, 1 kilonewton is 1 meter. That is 25.61 meter. Yani 25.61 kilonewton. Because 1 meter is equal to 1 kilonewton. So 25 meter means 25 kilonewton. So I will write here the force L0 U1 L9 at Rafter, because it is member of truss, okay, minus 25.614 kilonewton. Okay, L0 U1 and U9 L8, the value compression member. Easily you find out the graphical method. No calculation you are done. है ना? Now U1 U2. U1 U2. You see here in space diagram where is U1 U2? U1 U2. It is C to E, C to 2. So C to 2. Where is C to 2? This is 2 and this is C. So I have to measure this. Again I have to measure this and measure C to 2. It is coming around 22.768. So 22.768 is kilonewton. The force at U2. I will write down dead load in kilonewton because it is the compressive force. That's why 22.768 kilonewton. Okay, so this precision is we are getting in because we have drawn the space diagram in vector drawing in the AutoCAD by using the software. आप जब फ्री हैंड से ड्रॉ करेंगे हो सकता है कि वैल्यूज थोड़ी सी इधर उधर है, उससे कुछ फर्क नहीं पड़ता ओके, लेकिन ये कितना आसान मेथड है, कितनी आसानी से हम मेंबर फोर्सेस मालूम कर रहे हैं। सिमिलरली डेड लोड से U2 U3, so we have to find out U2 U3, U2 U3 D to 4, D to 4. So then I have to find out D to 4 how much? D to 4. This is 4 and this is D. D to 4 the value is 19 point. The value is D to 4. The value is 19.92. I will write down here. The value is 19 point minus 19.92 because of this compression. Similarly, U3 U4 U3 to 4 is not D to 4, sorry, E to 6, I think so. So U3 U4 member. This is U3 U4 member. E to 6. E to 6. I will go for E to 6. Where is 6? This 6 and this is E. I will measure this distance E to 6. Convert with scale. It is coming 17.076. I will write down here. Minus dead load minus 17.076. Similarly, the last number of inclined is U4 U5, and then here U5 U6 same, U4 U5 and U5 U6, this is same, so it is 8 to F. I will draw or measure a distance between 8 to F. This is the 8 to F. This is coming around 14.23. So I write down here. Because this is member after member, In gravity load, dead load, it is downward force. So therefore, in downward, that is in compression, is 14.230. Minus sign is for the compression. The sign is for the compression. Okay. Okay. So this one is compression member, and that's why. Also, you know that the force towards joint is always compression. The force towards joint is always compression, and the force away for joint is always in tension. So right hand like this. So you can find out this like compression and other forces by the grafter. तो अभी हम लोग ने सिर्फ राफ्टर के लिए वैल्यूज लिखे हैं, तो आपको यहाँ तक समझ में आ गया होगा कि हाउ टू ड्रॉ द की प्लान and then how to draw the space diagram, how to do the load analysis by Rafter diagram, okay, and then how to calculate the member forces in compression. Okay, this is I will stop here, and for other member, bottom tie, strut, and ceiling, we'll find out in next class, and then we will find out the member forces by wind analysis. Because live load and dead load are there are nothing but gravity load. So gravity load, by applying some factor, we can find out the live load. We don't need to draw this diagram. Okay, by changing, we know the load, external loads due to live load, and by applying the factor, we calculate directly in the table the live load. Okay, and then we will go for the Rafter diagram for wind load. Okay, this we have to draw in the sheet number 5. So this is nothing but your sheet number 5. Okay, and then you draw sheet number 6. I will explain what you draw in the sheet number 6. The sheet number 5 is containing key plan, key deviation, space diagram for dead load, is Rafter diagram for dead load. Okay. Now, if it is possible to draw Rafter diagram and space diagram for wind load, that also you can draw in sheet number 5. So it is, the lecture is very large. तो आपको समझ में आया सबको? Please you can open your camera and discuss with me. Hello, are you there or आप कहीं और चले गए? मैं लेक्चर ले रहा हूँ. हेलो, ऑल आर अवेलेबल? समझ में आया क्या? यस सर बोलने से नहीं होता है, काम करने से समझने से होता है. बोलिए. Can unmute and you can. देवरे, यासिर समझ में आया क्या?
यस सर.
समझ में आ रहा है. तो मैं ज़्यादा और आपको बर्डन नहीं डालूंगा. जितना मैंने आज समझाया उतना शीट आपका शीट नंबर 5 ड्रॉ करो आप. अगर आपको कोई डिफिकल्टी आती है, लेकिन वो आपका जो एग्जाम्पल है वो सोल्व करने का, मेरा कॉपी नहीं करने का. ओके. हाँ, मोहम्मद इब्राहिम क्या बोल रहे हैं आप? आपने हैंड रेज किया है. मोहम्मद इब्राहिम, एनी क्वेश्चन?
सर नथिंग सर.
नथिंग. हैंड रेज किया इसके लिए. और कौन है जिसको कुछ समझना है? आई थिंक सो सबको समझ में आ गया इसका मतलब. हाँ, तो इस तरह we will complete in next practical class. We will complete the force table and I will share that also with you. तो इस तरह एक एग्जांपल मैं पूरा सॉल्व कर रहा हूँ, इसका मतलब ये है कि आपको भी सॉल्व करना आना चाहिए। मैं सिर्फ आपको गाइडलाइन दूंगा इसके आगे, और आपको अपना ये फोर्स टेबल कंप्लीट करना है एंड देन शो टू मी। ओके, दिस इज द फोर्स टेबल। कोई प्रॉब्लम है आप पूछ सकते हो, कोई एक्सप्लेनेशन आपको चाहिए, दैट आल्सो यू कैन डिस्कस विथ मी। Shall we stop here and we will continue in next practical?